Fine. So welcome to the session. Yesterday we were talking about phase and time relation. So we'll continue that discussion. So we have talked about yesterday. We've talked about relation between phase and displacement. In today's session, we'll talk about the relation between phase and time. We have talked about phase here. So let us understand a little bit more about phase and time. Let's say the displacement is given as a sine omega t plus phi. Okay. So phase of the displacement or phase of the signal, let me call it as theta, is equal to omega into t plus phi. So the relation between phase and time is some kind of linear relation. See this one? As time increases by 2 seconds, theta also increases by omega into 2 times. Some kind of linear relation. If you draw a graph for theta and t, it is going to look something like this. Since this is looking like y equal to mx plus c, right? On x-axis, if you take time, and on y-axis, if you take theta, it is looking like this. Some kind of straight line relation between theta and t. Okay. Now, let us try to understand at time t1, sometime, some 2 seconds or 3 seconds, at some time t1, what is the phase? Some displacement will be there at time t1. Okay. Some displacement will be there, some phase will be there. Let us try to understand them. Displacement, let me call it as x1 a into sine of omega into t1 plus phi. I'm talking about some time t1. So if you take SHM, so segment 1, segment 2, from B to C, from B to C, first segment, C to D, C to B, another segment, and B to D is the third segment, and D to B is the fourth segment. Within these 4 segments, one cycle is completed. One motion, one simple harmonic motion of one cycle of simple harmonic motion is completed. Now we are analyzing at some time t1. This displacement happens at some time t1. That can be anything. It can be 2 seconds or 3 seconds, or it can be 5 seconds. But since we are talking about general thing, I'm saying it as t1. If you want to talk about a particular case, you can say it as 2 seconds or 1 second, something like that. Now, at this time, whatever is the displacement we got, this displacement is what we are calling as x1. Okay. And the phase at that time, let me call it as theta1. Let me call the phase at this point theta as theta1. And how much is that phase? Can you tell me? Phase and time relation. This is the phase and time relation. Simple relation. Whatever is the angle on which sine is applied, whatever is the angle on which sinusoidal signal is applied, that angle is what we call as phase or angle. Phase or angle is also fine, but in our textbooks they have used the word phase. That's why I'm going ahead with phase only. So what is the phase? You know what is the phase at any time? Omega into t plus phi. That is the relation between phase and time. Now, can you tell me what is the phase at time t1? At any time, you know, no? Since you want to time t1, just substitute t1. Omega into t1 plus phi. Is that okay? The phase at this particular time is omega into t1 plus phi. Next, similarly, let us analyze some other time. I'm taking some other time, some other than t1, any other time is okay. At this point or this point, any other time. Let me analyze at some time t2. Let us analyze at some time t2. At this time t2, what is the phase at this time? Theta is t2, theta 2, and the displacement happened till this point. The displacement happened till that point from B till this point. Whatever displacement happened, let us call it as x2. So displacement x2 is A into sine of at time t2. Displacement is displacement relation we know. At time t2, just substitute in place of time, just substitute t2 to get displacement at t2 time. We got the displacement. Let us talk about the phase at that time. What is the phase at that time? Only this part. Only this part is what we call as phase at that time. Omega into t2 plus phi. Phase is omega into t2 plus phi. Is that okay? Now let's calculate the phase difference. Let us calculate the phase difference between these 2 points. These 2 points are separated by time. What is the time difference between these two? Can you tell me? What is the difference in time between these 2 points? What is the difference in time between these 2 points? Anyone? This point we're talking about. So the particle is in such a motion like this. It is going on like this about the equilibrium. At some time, it is at this point, and at some other time, it is at this point. So this point happens in the return journey from C to B. This point happens on the journey from B to C. What is the time difference? What is the difference in time with which these 2 points are traced? What is it? T2 minus T1.
T2 minus T1.
Okay, is it visible? The blue. This is T2 minus T1. Okay, very good. So phase difference. Let's call it. Let us talk about phase difference. Phase difference. What is the phase difference? Can you tell me? This is the phase at time T1, and this is the phase at time T2. Definitely T2 is theta 2 is a bigger phase because it happens at a longer time. T2 is a longer time. No? T1 happens first and then T2 happens next. So the way we have taken it is T1 happens first, like it's like something like 2 seconds, then T2 is like 4 seconds, something like that. T2 happens later. No? So phase difference, which phase is greater? Theta 2 is greater. Which phase is lesser? Theta 1 is lesser. Let us take the difference between them. When you take difference between the phases, we call it as phase difference. Simple. Phase difference. And how much is that? Shall we calculate theta 2 minus theta 1? It is omega into T2 plus phi minus of omega into T1 plus phi. I'm taking difference between these two. Phi gets cancelled. It is equal to omega into T2 minus T1. So phase difference theta 2 minus theta 1 is equal to omega into T2 minus T1. Can I call it as delta theta? Phase difference. Delta means it represents the difference or change. So omega into T2 minus T1 represents change in time. No? So can I write it as delta T? Is that okay? So we got the relation between phase difference and time difference. A very simple relation, very simple relation. So let us write it once again in a little different manner. Can you tell me any formula for omega? Can we write omega in terms of T? Can we write omega in terms of capital T? Omega, angular frequency.
2 pi by T.
Very good, 2 pi by T. Or you can also write it as 2 pi f if you want to write it in terms of small f. Okay. Okay. So delta theta is equal to, can we write it as 2 pi by T into delta T? So we got a simple relation between phase difference and time difference. And it's a linear relation. See, as delta T increases by 10 times, delta theta also increases by 10 times. So there is linear relation between phase difference and time difference. Okay. Now, I don't think that this is some kind of formula you should remember. You don't need to remember also. Let us get this basic relation. Okay, I've analyzed the phase at some time, another time, and I've taken the difference. What I've done is very simple thing. I've taken phase at 2 different points, and I've taken the difference between the phases. Once we have taken the difference between the phases, we got a relation between difference between phases and difference between time difference and phase difference. Let us analyze with a common sense also. In a time period t, can you tell me how much is the phase covered? T means time period. Time period means time taken to complete one cycle of simple harmonic motion. This total thing, 1, 2, 3, 4, all this motion, 1, 2, 3, 4 motion happens in a time of t seconds. In a time of t seconds. In this t seconds, one cycle is completed. In a period, this is also periodic motion. So one cycle or one period is completed. So the time taken for one period, we call it as time period. We represent it using T, capital T. Time taken for one period or one cycle. What is the phase covered in one cycle? How much phase is covered in one cycle? Or phase, after how much phase is it periodic? Phase, after how much radians is it periodic?
2 pi.
2 pi radians, correct? Every 2 pi second, 2 pi. So you can see, you can draw a circle. So if you measure anti-clockwise, one cycle is completed. What happens? 2 pi radians is completed. After that, you are traversing the same points. No, every 2 pi you are traversing the same point of the circle, right? So one cycle, the phase covered is 2 pi radians. So t seconds time corresponds to 2 pi radians. From that, can you tell me what does theta radians correspond to? If 2 pi radians corresponds to t seconds of time, how much does theta radians correspond? If you want, just write it as, let's divide with 2 pi both sides. Let's divide with 2 pi both sides. Then 1 radian of phase corresponds to t by 2 pi seconds. T by 2 pi seconds of time. For 1 radians, the time taken is t by 2 pi means for theta radians, how much is it? For 1 radians, it is t by 2 pi seconds. For theta radians, how much is the time taken? For 1 apple is 10 rupees. 10 apples is how much? Same funda. 1 apple is t by 2 pi rupees. Theta apples, how much is it?
T by 2 pi theta.
Into theta only, no? Is that okay?
Yes, sir.
Okay. Or the other way of asking is, in small t seconds, how much is the phase? What is the phase corresponding to t seconds? Let us calculate for 1 second in this, for this and this, both sides. Let's divide with capital T. If you divide with capital T, what remains is t by t is 1. 1 second, how much is the phase covered? 2 pi by t radians is the phase covered. That is what we are calling as omega. The phase covered in 1 second is what we are calling as angular frequency omega, right? So in 1 second, if 2 pi by t radians is the phase covered, in t seconds, how much is the phase covered? 2 pi by t into t. In 1 second, this is the phase covered. In t seconds, how much is the phase covered? 1 second, it is this much. In t seconds, it increases by t times, no? Is this same as what we have discussed now? See, 2 pi by t into t. We are representing it as delta t because we're talking about phase difference. Delta t corresponds to some time, no? Okay, I hope you're following. What I'm trying to say is, this is not a big deal of a formula. You can get it from the very commonsensical basics. Okay. Okay. So I hope you have understood the difference. You have understood the relation between phase difference and time difference. So if somebody gives you time difference, substitute here, you can get phase difference corresponding to that time difference. Or they have given you 2 points. Okay, and between those 2 points, there is some time gap in which the same particle traverses both the points. The particle first comes across this point. Now after some time, it comes across this point. There is some time gap between the time the particle touches this point and then this point. Or the particle takes displacement and the next this displacement. There is some time gap. That time gap, we are calling it as time difference. And for every time, there corresponds to phase. For every time, there corresponds a phase. So since there is a phase corresponding phase for every time, since there is time difference between these 2 points, there will be some corresponding phase difference also. Now, once you know time difference, you can get the phase difference. See, using this using this formula, from time difference, you can get the phase difference. If you know phase difference, you can get time difference. Delta t is equal to delta theta into t divided by 2 pi. Something like that. You don't need to remember everything, okay? If you forgot this also, see this one, phase difference and time difference. You know what is the phase? You know what is the phase? At 2 different times, what is the phase? You know, you just subtract them, you'll get this relation, very simple relation. Okay. If I am remembering, I'll remember this part. If at all, if you have to remember only this much. If you forget this, no problem. Where did you get it? You take the displacement equation. In that, you know the phase omega t plus phi. At time t, at time t1, it is omega t1 plus phi. At time t2, it is omega t2 plus phi. Take the difference between the phases. It will be omega into t2 minus t1 is the phase difference. So phase difference equal to angular frequency times time difference. Simple relation. Time difference multiply with angular frequency, you'll get phase difference. As simple as that. Okay. Okay. Let me ask you some questions. Okay. 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 If the time gap is 2 seconds, then can you tell me the corresponding phase difference? If the time gap between 2 points of SHM motion is 2 seconds, can you tell me what is the phase difference between those 2 points?
2 omega.
Very good. In 1 second, how much is the phase difference created? That is what is angular frequency, you know.
Yes, sir.
Correct? In 1 second, whatever is the phase change, that is what is angular frequency. Okay, angle change that happens in 1 second is what we call as angular frequency. Forgetting, even if you don't understand that part, you know this formula. If I'm saying time difference is 2 seconds, substitute 2 here. 2 into omega is 2 omega. That is the phase difference. If you know omega, any problem, they'll give you what is omega. You can substitute that also. Okay, fine. So Narahari, you can tell me this. If the time gap between 2 points is 10 seconds, then can you tell me what is the phase difference?
It will be 10 omegas.
Okay. Next, Venki, I'm asking you, if the phase difference between 2 points is 2 pi, if the phase difference between 2 points is 2 pi, can you tell me what is the time difference between them?
2 pi omega.
Oh, I've changed the question. I've given you phase difference. I'm asking you time difference. I've given you this as 2 pi. I'm asking you delta t. I'm asking you time difference. What is it? Come on, you should not take this much time. Delta t is equal to 2
2
pi
by
by
10.
omega. So if you give given phase difference, you can find time difference. If time difference is given, you can find phase difference. Okay, fine. Okay. I'm going to the next slide. I hope it is clear till this point. Any doubts? Rishika, following?
Yes.
Purnashri?
Understood, sir.
Yes, sir.
Okay. Okay, this is the equilibrium position. As usual, I'm taking the same diagram. Now that we have the understanding of phase difference and time difference, now let us analyze further at every point what is happening. Let us assume at time 0, the particle is at equilibrium position. Let us assume particle is initially at mean position. Particle is initially at mean position. From this, what is the information that I've given you? What information have I given you? Have I given you about information about displacement? Or I have given you information about initial phase? What did I give you?
It is at equilibrium.
Okay, that is what I told you. Mean means equilibrium only, no? Initially, if I have told you the position, right? Initially, position means what I have given you. Have I not given you displacement? Have I given you displacement or not? Initial displacement, I mean initial displacement, starting initially, whatever is the displacement, that is what we call as initial displacement. We have talked about initial displacement, initial phase, right? Correct? Okay. Now tell me, so what did I tell you? Particle is initially at mean position. Initially, whenever somebody says initially, they are talking about time 0. At t equal to 0, what is the displacement they're saying? A cos omega into 0 plus phi, which is A cos phi. Okay. Now, what is the displacement that is given here in this problem? In this question, I have given some information about initial displacement. What is initial displacement I've given you? Displacement is always measured from the mean position. I told you the initial position is here itself. So what is the initial displacement, Meghana?
0.
0. Okay, displacement is measured from the mean. And I told you that it is at the mean only initially. Initially means what? Not before starting SHM. It's not like that. It's when you start observing. SHM is already happening. Whenever you start observing, at that point, at the time when you have started observing, the position can be anything. It can be at the maximum position, extreme position, or at the equilibrium, or at the middle also it can be. That information will be given in the problem. Based on that, we have to analyze. Okay. We'll talk about other positions as well, initial position as other position also. But for now, with this information, can you find what is the initial phase? A cos phi is 0, which means cos phi is 0. What is phi?
90 degrees.
Oh, is it? Oh my, 1 second. Correct. Cos is phi is 90. Very good.
Pi by 2.
Or 3 pi by 2 is also right now.
Yes, sir.
So
Yes, sir.
some information is missing. I told you that it is at mean.
Direction.
Yes, very good. I did not tell you the direction. That information also should be given. Correct? So if that information is not given, you'll be confused whether it is pi by 2 or 3 pi by 2, because cos pi by 2 is also 0. Cos 3 pi by 2 is also 0. So I should give you the direction to remove that ambiguity. So I should give that information also. So I have not given complete information here. I should give the direction as well. Particle is initially at mean position, moving towards positive direction or a positive x-axis. Then now what is the phase? Can you tell me? With this, I think there should be ambiguity should be removed. So what is the phase? Because I told you that it is positive direction. Okay. If it is negative direction, then it is the path first path, second path. When it is after second path is completed, it will be at the equilibrium position again. Okay, it will be at the equilibrium position again. So when a system started, this is the equilibrium position. The starting motion will be something like this, and then it moves like this. So it will be at equilibrium in a cycle 2 times. One while going towards positive direction, another time while going towards negative direction. Okay. So since it is first time. Since it is positive direction, in the whole cycle, it happens first time according to the given information. Among the two phases, the first phase will we have to choose, or the first time corresponds to first phase. Okay, here I have taken cos. You have to mind this. Yesterday I was taking sine. I've taken cos to tell you that you can take anything, cos or sine, anything is okay. But stick to one thing while doing problems. But if you take anything, still you'll get the same answer. That is what I wanted to convey here. Okay. When it is at equilibrium position, that corresponds to generally zero phase. As it moves further, phase increases, time increases, phase also increases. As it comes back, phase increases, time increases. As it goes on to the other side, time increases, phase increases. As it comes back to the equilibrium position, time increases, phase increases. Okay, and again phase starts from zero. Once one cycle is completed, again phase starts from zero. Because phase, we measure it from 0 to 2 pi. 2 pi to 4 pi measuring or 0 to 2 pi measuring, both are exactly same. Okay, now since we have figured out that phase is pi by 2, now can you tell me what is the equation of this SHM? What is the equation of this SHM? X equal to a cos of omega t plus pi by 2. What is cos of omega t plus pi by 2? Can anyone tell me? I told you a technique in last previous session. Cos of
Sine.
theta plus pi by 2. When you add or subtract with pi by 2, it will definitely be sine. But there is a minus sign or not, that is the question. If you want to figure out whether there is a minus sign or not, substitute some value and see.
Sine pi by 2.
Very good. Substitute some pi by 2 here. Because if you substitute 0, sine 0 will be 0. On the other side also 0. Zeros we can't figure out whether there is a minus sign. So theta, if you substitute pi by 2 here and here, sine pi by 2 is 1. Okay, and cos of pi, this is pi by 2 plus pi by 2 is pi, cos pi is minus 1. So that it is not matching. It will be matched only if there is a minus. Okay. Instead of omega t, I have taken theta. So if you want, you can write it as cos of omega t plus pi by 2, sine of omega t. Anything is fine. So when you add with pi by 2, it will be minus sine, minus a sine omega t. Is that okay? Fine.
Yes, sir.
Okay. Same problem. Let us take it like this. A into sine of omega t plus phi. You can take it like this also, no? So time 0. What is the displacement? It is 0. A into sine of, this is 0. At 0 time, it is this part is 0. So this implies sine phi is 0. This means phi should be either 0 or pi. Can be initial phase can be 0 or it can be pi. Since it is moving towards the positive direction, at time 0 it is here. At time 0, since it is we are talking about movement from here, because it is moving towards positive direction, you have to take the 0 phase. So if you take 0 phase, x equal to a sine omega t plus 0, because 0 is the initial phase. But we are getting differently, right? There is some mistake that we have done. That is why we are getting it differently. Minus sign we got here. So I think this is correct, because sine, with sine there is no confusion actually, because when phase is 0, the amplitude is also 0. The starting position will be equilibrium. But when you put phase Fi 0, you're getting cos as maximum value. Okay. Yeah, let me explain. Here in this case, we have not taken cos till now. So there is a mistake here. So we should be taking 3 pi by 2. Why we should take 3 pi by 2? I'll tell you. Okay. If phi is 0, then can you tell me what is the displacement? A cos omega t, correct? Now, at time 0, what is the displacement? Is it not
0.
maximum?
A.
Cos
A.
0 is 1, right? So, when it is phase 0, in cos, when you're taking cos, phase 0 corresponds to this point. The motion starts for phase 0 in cos. Whenever somebody says phase 0, when you're taking cos, it means it starts from this point. Okay. When you take cos, it is like that, because that is how it is. That is how the function is. Cos omega naught t takes, when you the initial phase is 0, at time 0, if the phase they say it is 0, it means it is starting from here. If it is starting from here, if you're taking cos, then the initial phase here is 0. This phi equal to 0 means this corresponds to t equal to 0 when you're taking cos. Okay. Now this corresponds to time 0 or phase 0. Then when you come here, the phase will be pi by 2, but the direction is in the opposite direction, in the negative direction. And when you come here, the phase will be pi, and when you come here, the phase will be 3 pi by 2. So when you're taking cos, the measurement starts from the extreme position, on the right side extreme. You should start measuring the phase or time from the right side extreme. Okay. Whereas when you're talking about phase 0, here, if phi is 0, what is displacement? A sine omega t. If you take initial phase as 0, and if you're taking cos signal, then it means the initial displacement is the extreme position. Whereas when you're taking sine function, and if the phase is 0, displacement equation is given as A sine omega t. And now at time 0, what is the displacement? A sine 0 is 0, right? When you're taking sine function, when the phase is 0, at time 0, it is having 0 displacement. So the convenience of sine function is at 0 phase, if it is having 0 phase, at time 0, it indicates 0 displacement. So when you're taking sine function, it's much more easy to understand. So trying to measure from equilibrium position is more easy. So when you take sine function, and if the phase is 0, at time 0, you can understand that it is starting from this position. Okay, and as you go from here to here, the phase will be pi by 2. As you come here, phase will be pi. As you go here, 3 pi by 2. As you come again here, it will be 2 pi. Okay. So when you take sine or cos, the situation is different. But finally, you should end up with the same answer. But for sine, basically, when you take phase as 0, time as 0, you can assume that the analysis or the observation start from this position. Okay. Whereas when you're talking about cos, the observation starts from here. Okay. I think this is a little bit confusing. To remove the confusion, I'll take one more example, then it will be better. If phase is pi by 2, if phase is pi by 2, then can you tell me what is displacement? A cos omega t plus pi by 2. What is the initial phase? Pi by 2. Mind this, what is the initial phase? Pi by 2. Okay. For cos, when you're taking cos, if the initial phase is 0, initial phase will always give you initial displacement, or initial position you have to observe carefully. Initial phase and initial displacement, they are related. Initial displacement will give you initial position. Where is the initial position? When you have started observing, what is the position of the particle that is in SHM? When you're taking cos, this is the reference position. You are starting measuring from this position. Okay, you are starting measuring from this position if the phase is 0. But if the phase is pi by 2, where will you start measurement? Where is your observation? Where is the particle? What is the position of the particle? If the phase is 0, this is the position. But if the phase is pi by 2 plus pi by 2, what is the initial position of the particle? What is the initial position of the particle? See, motion happens like this. 1, 2, 3, 4, right? When you are taking cos, this is the reference position. And when you're taking sine, this is the reference position. The phase is 0 for sine, this is the reference position. If the phase is 0 for cos, this is the reference position. Now try to understand. Initial phase here is pi by 2 plus pi by 2. From this point, plus pi by 2 means what point or what does it corresponds to? Phi is 0 means this point. Phase pi by 2 means this point, no? You're talking about this as the initial displacement, initial position. If the phase is pi by 2, and if you're taking cos, and if the phase is pi by 2, for cos, the measurement starts from here. When somebody says phase is pi by 2, you're talking about this position. So when you started observing, the particle is at this place. Don't think that cos is there means always the starting position is here. The starting position is here only if the phase is also 0. Cos with phase 0, it is the position here. Cos with phase pi by 2, it is the position here. Cos with phase pi, it is the position here. Initial position is here. Cos with phase 3 pi by 2, the position is here. Okay. Cos with phase pi by 4, the position is here. Cos with position with initial phase pi by 3, the position is here. You start measuring from here. Okay, I hope you're following. So if you want, you can substitute at t equal to 0. What is the displacement? Substitute t equal to 0 here. This will become 0. Cos of pi by 2 is 0.
Minus.
0 only, no? I'm substituting t equal to 0. Okay, and let's not convert it into sine. Let's
Okay.
convert it into sine. If you want, we can also convert it into sine. Okay, what is it? What is this value? If you convert into sine from the previous analysis, it is minus a sine omega t. Correct?
Yes, sir.
Initial phase of pi by 2 using cos means we know the position. Try to imagine whatever they give you, cos or sine terms. Try to imagine it. Try to pick the point that they are talking about in this graph, in this SHM motion, in this 4 paths that we are taking. In that 4 paths, what is the initial position that they are talking about? You have to imagine it yourself. Okay. Once we analyze this, once we become comfortable with both cos and sine, we will stick to sine only. Okay, because sine has little bit of convenience that initially when the phase is 0, it starts from the equilibrium position. Let us do the same analysis here. Phase pi by 2 corresponds to this point, right? Phase pi by 2 corresponds to this point. This is B, C, and D. B to C, C to D, C to B, right? C to B. When it is coming, once it comes from C to B, that position is what we are talking about here. Okay, that is the point that this is the point that we are talking about now. This point, can you tell me what is the phase difference from this point to this point? Anyone? No? Okay.
Hi.
Very good. Very good, Meghna. Observe carefully. You have to focus very, very well. Little bit of time. Let's wait for some time. Once you understand the basics, everything else will be easy. Okay. Now let's say we are starting at this place, t equal to 0. Tell me what is the time taken to reach this place? Let's say we are at this place at time 0. We are at this place means if you're taking displacement function as sine omega t, a sine omega t, you're taking function as a sine omega t plus phi, that phase you are taking it as 0. That phase if you're taking it as 0, then it means the starting position is this point. You're taking this function. If you take phase as 0, at time 0, the total phase is 0. So it means this is the position when you're taking sine function. When you're taking cos function, this is the position corresponding to initial phase 0 and time 0, right? So if this is the position at time 0, if this is the position at time 0, what is the time taken to go from here to here to here, and then from here to here? What is this total time? What is the total time taken? Time period we call it, right? This total path is 1, 2, 3, 4. So time taken to travel from 1, time taken for this path is T1, let me call it. Time taken to traverse this path is T2. Time taken to travel the third path is T3 and T4. All of that together, one time period. To complete one cycle, the time taken is one time period. The time taken to travel from this point to this point and this point to this point, they're all equal, right? Time taken to travel first path, second path, third path, fourth path, they're all same, correct? They're all equal, right? How much is this time? You know the total time taken to complete one oscillation or one SHM motion, one period, once it is completed, one cycle is completed. The time taken to complete one cycle is capital T. Time to go from here to here, here, and here. All the 4 paths to travel, the time taken is T seconds. Now tell me, what is the time taken to traverse 1/4 of it?
T
What is
by
the time taken to travel 1/4 of it? T by 4 only, no? 1/4 of the time, because they're all equal, no? To time taken to go from here to here or here to here, both are same, they are equal, right? And from here to here, they're all equal. All the 4 times time taken to go from mean position to extreme and extreme to mean, mean to extreme, extreme to mean, they're all equal. They're all equal in amount of time taken. So time taken for the second path is also T by 4. Time taken for the third path is also T by 4. Time taken for the fourth path is also T by 4. Okay. Now tell me, how much is the time taken to travel from this point to this point? Come on. Just now we've discussed. From this point to this point, what is the difference in time? T by 4. No, to come
T by
from
4.
to here, what is the time taken? T is the total time taken to complete one cycle. In that, only 1/4 of the time, because there are 4 paths. No, 1, 2, 3, and 4. 4 paths. All of them take equal amount of time. So the time taken to travel from the mean position to the extreme position is how much? T by 4.
T by 4 seconds.
So what is the time taken to reach this position? So this point and this point both are same, okay? These two are same points. What is the time taken to go to this point?
T by 2.
T by
Here
2.
to here, T by 4. From here to here, another T by 4. So total is, can I say T by 2? From here to go here, from this point to reach this point, from mean position to go to extreme and then come back to mean position, what is the time taken? It is half of the time period. Correct? Half of the time period, T by 2. Next, to go to this point, how much is the time taken? From this point to this point, we know the time taken is T by 4. From this point to this point. But from this point, if you measure, from this point, if you are trying to measure, how much is the time taken?
T.
They only don't have clarity.
See, this is T by 4 plus T by 4 to reach this point. To reach this point, another T by 4. 3 times T by 4 only, no? Correct? Following?
It was not with us.
Yes, sir.
Yes.
Okay. Now let me ask you one more question. From this point to this point, another T by 4 seconds will be taken. Time taken to go from this point to this point is another T by 4 seconds. So what is the total time taken to reach this point again? The particle will be again at this position again after how many seconds? T
T
seconds.
second.
Correct. Next, what is the next time after which it is here? At T seconds it is here. Next, after again T by 4 seconds, it has to go to this path, to go to this place, no? So can I say it is 5 T by 4?
Yes, sir.
Again, after t seconds, you will reach this point again, second time after t seconds. T by 2,
Yes.
t by 2 seconds, you have reached this. Again, after t seconds, because it is periodic with t, no? Same thing happens after every t seconds. So add t to this, you'll get 3t by 2. Or add t by 4 to this. From here to here, it will take 2t by 4 seconds. So 5t by 4 plus t by 4 will give you 3t by 2. Next, what is the next time after which you reach this point? What is the next time after which you reach this point? You know, this point is repeated again after t seconds. So add t to this, you get 7t by 4. That is one way of getting it. Or this point you have reached the second time at 3t by 2 seconds. Add t by 4 seconds to that. From here to here, it will take t by 4 seconds. Okay. I hope you're following. This is 7t by 4. Now tell me, what is the time at which it reaches this point again?
It will be 2t, sir.
2t. I hope you're following. Right? Now let me ask you. Now let me ask you some questions. Harsha, let me ask you the first question. Can you tell me what is the time taken to go from B again to B? What is the time taken to go from B? Start from B, travel, and again come back to B. What is the time taken?
T by 2, sir.
Very good. Yes, it is T by 2. Next, Meghna, what is the time taken to go from C to D?
T by 2.
Very good. One more question for you, Meghna. From C, I am going to B in the positive direction. What is the time taken? From C, I am reaching B in the positive direction. What is the time taken?
T by 4.
In the positive direction. C to B, you can reach C. From C, you can go to B at this place or at this place. There are two ways of going to B. From here to here or here to here. You can't go this way, okay? C to B, you can't go like this, okay? You can't go like this. This is not the path. This is the path. From B, you go to right side and then come left side and then go to the extreme and then come back to B. There are two ways of reaching B. From extreme position, you are coming to mean position. But while coming to from C to B, initially, you are traveling in the left side direction. And I'm talking about right side
T,
direction. C to B and then B to D and then D to B. I'm talking about this total time from C to B. This total time, this three paths I'm talking about.
3T by 4.
3T by 4. Hope you're understanding.
Yes.
Next, Venki, let me ask you, what is the time taken to go from D to C?
From D to C, sir.
Yeah,
T by 2.
very good. Hari, Narahari,
Sir,
what is the time taken to go from C to D?
negative direction, sir.
C to D, any direction. Only one path is there from C to D.
Okay.
C.
It will be T by 2, sir.
Very good. One more question for you only. What is the time taken to go from D again to D? D to D. After how much time will come back to the same point? That is what I'm asking.
T seconds.
Correct. Purnashri, what is the time
Yes,
taken
sir.
to go from D
No, I'm just asking. No, I'm just
in the
asking.
positive direction?
5 by 4. T by 4. T by 4.
T by 4. Okay. Okay. Rishika, what is the time taken to go from B and come back to B?
Sir, go from B to
Come back to B.
T.
B to B.
T, sir.
Extreme positions you'll reach only after T time. But equilibrium position, you reach twice in the same time period.
2t.
No. From C, if you again want to reach C, you go to B, B to D, D to B, and then C to C. It takes one time period to reach the same point, same extreme position. But the points in between, you traverse twice, no? You touch each point in between. Only extremes you touch once in a time period, but the in between points you touch twice. Correct? So I'm saying B to B. I did not specify any direction. Okay. When somebody does not specify any direction, you take the shortest time or shortest thing. So for B, you go to C and then come back to B. How much is the time taken? B to C, it is T by 4. C to B, it is again T by 4.
Yes, sir.
Okay. How much?
Understood.
T by 2 only, no?
T by 2. Yes, sir.
At T also it will come to B. Agreed.
Yes, sir.
Okay, but T by 2 also it comes to B, no?
So so we have to take the shortest times.
It's not like that. Question will be more clearer than this. Okay, but when you
Okay.
travel when this diagram, if you take from B, you go to C and then to B. Okay, or
Okay.
from B to D and then to B, then also it is T by 2 you are getting, no?
Yes.
Or else if I ask you, I'm going from B and then I'm coming to B in the same direction. Whatever direction I'm starting from B, same direction I'm reaching B. Now tell me what is the time taken?
Then it will be T, no, sir.
Then it will be T. So I have clearly mentioned about direction, no?
Yes, sir.
Yeah.
Understood.
Okay. So I hope you are clear with time.
Yes, sir.
Yes.
Now,
Yes,
shall we link phase with this? Let's link phase with this. At time 0, let us assume phase is also 0. Let us assume phase also 0. Now tell me, what is the corresponding phase to this point? What is the phase that corresponds to this point?
Pi by 2.
Very good. This T corresponds to 2 pi. T by 4 corresponds to what? 2 pi by 4, which is pi by 2. One path, all the 4 paths, they correspond to a time difference of time taken to traverse one path among the 4 paths that we have written is T by 4. So phase covered in that time is pi by 2, because the total phase is 2 pi. If you make divide the 2 pi into 4 parts, each part is pi by 2. So what is the phase difference between B and C? What is the phase difference between B and C?
Pi by 2.
Same phase here also, because it's the same point. We are just for convenience we have drawn it separately, C and C. So what is the phase here? It
Pi.
takes pi by 2 radians to travel from B to C,
Pi.
phase wise. B to C, pi by 2 radians. C to B, again another pi by 2 radians. From C to B, time taken is T by 4. From C to B, phase changes pi by 2. So what is the total phase starting from here? If the phase is here 0, what is the phase here? From
Pi.
here to here pi by 2. From here to here pi by 2. Total it will be pi.
Pi.
Okay, Harsha, can you tell me the phase here?
Sir, can you say the point, sir?
What is the phase here? If the phase is 0 here, what is the phase here? Same way we have analyzed time, we are trying to analyze phase. What is the phase difference between B and D?
Pi by 4, sir.
Pi by 4, pi by 2, no? Phase difference between B and D, any path takes a phase difference of pi by 2, time difference of T by 2, T by 4. See here, time difference of T by 4 corresponds to phase difference of pi by 2. If you're confused, you know the basic difference. Phase difference is equal to omega times time difference. So we're talking about time difference of pi T by 4. Substitute here T by 4. We'll get the phase difference. So omega, we can replace it with 2 pi by T, because there is T here to get, we can cancel that. You can calculate it like this also. Time difference of T by 4 corresponds to phase difference of pi by 2. That way also we can calculate.
Yes, sir.
Okay. So phase difference between B and D points is pi by 2. But what is the phase difference between the B point till D point? There is phase 0 here, it will be pi by 2 here, it will be pi here, it will be 3 pi by 2 here at D. And what is the phase here again? What is the phase here again?
2 pi.
2 pi. Very
2
good.
pi.
Okay. I hope you're following.
Yes, sir.
Okay. Okay. So let us discuss the same thing with cos. So by default, you go ahead with sine. Okay, this is more convenient. Okay, or else I'll talk about sine only, but in a different way, with a different phase. Let's talk about it. Okay, let's take the phase as some pi by 4. Is it okay? Same analysis. Initial phase, I'm not taking it as 0. I'm taking it as pi by 4. Now let's draw the same diagram. Who wants to tell me what is the starting position? So shall we analyze the initial displacement? At t equal to 0, what is the displacement? A sine pi by 4, correct? What is that? Sine pi by 4 is 1 by root 2. So it is a by root 2, right? What is a by root 2? What is the position of a by root 2? Somewhere here. Somewhere here. This is the position corresponding to, this is the initial position which corresponds to t equal to 0. Why is the position here, not here? In the previous analysis, the position was here. This is the initial position because phase was taken to be 0. Initial phase is taken as 0. But now, initial phase is taken as pi by 4. So that's why the initial position at which we are starting observation is here, somewhere here. So this displacement is 1 by root 2 or a by root 2. If this total length is a, then at a by root 2, because it is plus a by root 2, this is the point. Okay. Now tell me this. When you're traversing from 0 to pi by 4, pi by 2, so from B to C when you're going, from B to C when you're going, from B to C when you're going from 0 to pi by 2, correct? Similarly, when you go from C to B, what is the phase change? Pi by 2 to pi. You're talking about this point you're getting it twice, no? You can come across this point twice, right? Understand this carefully. What does this point correspond to? This point corresponds to what phase? Phase equal to pi by 4. And the same point here, the phase distance between these 2 points, this point and this point, is pi by 4. So this point and this point phase difference also is pi by 4. Okay, so what is the phase here? Anyone can tell me what is the phase here? This point corresponds to when you're going from mean position to extreme position, you can come across some point where the phase is pi by 4, or the displacement is a by root 2. Say once you reach the extreme position, you come back to the same position in the reverse direction. At that place, what is the phase? From here to here.
Pi by 4.
Very good. So this point and this point has a difference of pi by 4 phase difference. So this point and this point has again pi by 4. But this point is ahead of this point because you come across this point, and after that, when from extreme position you're coming back to this position later. This point is coming late. This point is coming late. In this path, this point comes first, C, and then from C you are coming to this point late. This point is coming, you are coming across this point twice. Once while going to the extreme, once while coming back from the extreme. While going to the extreme, when you come across this point, then the phase is only pi by 4. Because the time at which you come across this point is also smaller. The time at which you come across this point also will be smaller. So that's why the phase also will be smaller. After some time, you come across the same point again. After some more time, the phase also will be more. What is the phase here? This distance is pi by 4. So pi by 2. After pi by 2, another pi by 4 phase, you come across this point, which will be 3 pi by 4. Hope you're following.
Yes, sir.
When I say pi
Yes,
by
sir.
4, when I say pi by 4, I'm marking this point. When I mark this point, when we mark this point, there is a confusion whether it is while going to the extreme or coming back from the extreme. Okay, but from the phase, it is very clear. It is pi by 4. So when you're taking sine, your measurement is relative to, with respect to mean position, you measure it from the mean position. From the mean position, pi by 4 means we come across this point while going to the extreme. It is in this path. We'll talk about this point in this path. If the phase was 3 pi by 4, so this is the mean. From mean position you measure from here to here, it is pi by 2. 3 pi by 4 means from pi by 2 another pi by 4. So while traveling back, this is the position that should be taken as initial displacement or initial position while coming from extreme, only if the phase here was 3 pi by 4, not pi by 4. Okay, so by looking at a by root 2, you'll mark this point. You mark this point, but this point is this point or this point while going to extreme or coming back from extreme. That you can identify, but with the help of phase only. With the help of phase only. Pi by 4 indicates it is this point, the point on the first path. Okay, is it clear till this point?
Yes, sir.
Okay.
Okay, now can you tell me what is the time corresponding to this point? This point in this diagram, what is the time corresponding to this point? You know the phase about that point, right? Phase of that point. If you know the phase of that point, can you tell me the time corresponding to that point? T by 4 corresponds to pi by 2, no? So then pi by 4 means half of this. It corresponds to what time? Come on.
Which point, sir?
This point, this one. This point.
Not able to see which point you're mentioning.
Oh,
Yes.
Pi by 4 phase corresponds to what time? See this relation. Take this relation. Pi by 4 is equal to omega into delta t. Omega is 2 pi by t into delta t. Pi by 4. Pi gets cancelled. So delta t is equal to t divided by 8, no? Okay. So from here, you reach this point whose displacement is 1 by root 2 or a by root 2 after how much time? After t by 8 seconds. And the phase is pi by 4. The phase change from B to this point is pi by 4 and the time changes t by 8 seconds. Is that okay? Now can you tell me the time corresponding to this point? Time corresponding to this point C is, we know that it is t by 4. What is the time corresponding to this point? Anyone? From here to here, time taken is t by 8. From here to here, another t by 8. That is why it is total time is t by 4. The time taken from here to here is t by 8 means time taken from here to here is also t by 8. Time taken till this point, we already know it is t by 4. From this point to this point, we know from the previous discussion, it is t by 8. So what is the time taken? T by 4 plus t by 8 is 3t by 8. Or else you know the phase, no? You know the phase, right? If you know the phase, substitute the phase here, you get the time. Substitute 3 pi by 4 here. Then you'll get 3t by 8. We're talking about simple relation between time and phase. If you can understand this carefully, once the confusion gets removed, everything else will be very easy. The problems become so easy. Okay. Fine. So let us talk about this one. Okay. I'll discuss a few more things like this. So I think the confusions will be cleared. Right. So now you know the initial point. This is the starting point. Okay. Let me mark it with red. This is the starting point. Here, this is the starting point. You start measurements from this point. Okay. From this point. If it is sine, you start measuring from this point. Okay, and since initial phase is pi by 4, you start measuring from here. Now tell me this. What is the time gap between these two? Anyone? What is the time gap between these two?
T by 8, sir.
From here to here, how much is the time taken? T by 8 seconds, no. Time taken here is, time gap between these 2 points is
T by
what is the time gap between these 2 points? Another T by 8 only, no? Because what is the time corresponding to this point? I mean, the total time from here to here.
T by 4, sir.
4, no? So this part will be T by 8, this part will be T by 8. Now you'll ask me one question. Sir, these are unequal, no? They have not drawn unequally. See that whatever length I have drawn, that is about displacement. And we are talking about time. Okay, we are not traveling with same velocity, right? If you're traveling with same velocity, then same displacement will be covered in equal times. But are we traveling with same velocity? Is the velocity more here? When it is coming from the mean position, it has a huge velocity, no? It has the highest velocity. If it has highest velocity, it can cover more displacement, no? As it is going to the extreme position, its velocity is reducing. So here, in this region, its velocity is very less. Its velocity is very less. That's why it is covering smaller distance. Time-wise, these two paths have equal amount of time, but their displacements are not equal. Mind this. If time change is same, phase change also will be same, no? How much is the phase change? How much is the phase change? T corresponds to 2 pi. T corresponds to 2 pi. T by 8 corresponds to, just divide with 8, no? 2 pi by 8, which is pi by 4.
Pi by 4.
This T by 8 corresponds to another pi by 4 change. Amount of time change and phase change are same, but the displacement covered is not same because the velocities are different. That's why. Okay. Now, if this is time 0, can you tell me what is the time here? And after how much time? If this is the position at which you have started observation, after how much time you will observe this point to be reached by the particle? This point you have started observation. This is the time 0 point. At time 0, you have observed that the particle is going in the right direction, right side direction at this point. Now tell me, after how much time it will reach this point C? The time gap.
T by 8 only, sir.
How much?
T by 8, sir.
T by 4, no. Sorry, T by 8. Yeah, my mistake.
Yes.
T by 8. T by 4 means it's the total first path. It will take T by 4. Since we're talking about only half of the time, T by 8. Very good. So now can you tell me how much is the time taken to get to this point? From here to here, T by 8. While coming back also, it will take same amount of time.
T by 8 only, sir.
This length is covered in T by 8 seconds. This displacement is covered in T by 8 seconds. And this displacement is covered in, this is a bigger displacement, which is also covered in T by 8 seconds because the velocity is increasing. So how much is this value? From time 0, how much is the time taken to get to this point? Till here it is T by 8 seconds. From here to here, another T by 8 seconds.
T by 4.
Moving, right? Is my cursor moving? Is my cursor moving?
We are not able to see the cursors.
Yes,
We are
sir.
able to see the writing on.
Okay, minus. Yeah, that's what I have recorded yesterday also. In recording also, I'm not able to see the cursor moving.
So we are not able to see those point where you are. So
Yeah, I understand that, but I don't know. I figured out a lot of things, but how to move this marker, I'm not understanding.
it moves for some time, sir, but it stops.
Okay. Sometimes it is moving, sometimes it is not. Okay.
Yes.
Yes, sir.
When you are changing the slide, it will be like for 5 minutes it will be moving, then it will stop moving.
Oh, for continuously for some time it is moving, no?
Yes, sir. For some time it will move, then it will stop.
Now it is moving. Okay.
No, sir.
No. Okay, fine. Let us adjust. I'll figure out some other way. Okay. So I'm using different techniques to different apps to teach. So I have to figure out. I have one app where the cursor will move, but the problem is that app has other disadvantages. Anyway, we'll figure it out. So can you tell me from here to here, What is the time taken from here till this, from this point to this point? What is the time taken? T by 4, correct? To this point,
Yes, sir.
what is the time taken? What is the time taken to this point? Another t by 8 seconds, no?
3t by 8.
Very good, 3t by 8. From this point to this point, how much time? You know, from this point to this point, what is the time gap? What is the time gap between these 2 points?
T by
T by 4.
T by 4. So can you tell me what is the time taken to reach from the initial time till this point? Another t by 4, 3t by 8. Just add t by 4, you'll get it. 3t by 8 plus t by 4. How much is that?
5t by 8.
5t by 8. Very good. Next, what is the time taken to reach this point? So time taken to go from D to B is again t by 4 seconds. To come here, it is 5t by 8. From 5t by 8, another t by 4 seconds. How much is it? 7t by 8.
70.
What is the time taken to reach this point finally? The starting point.
T.
T.
Very
T,
good.
sir.
We know it is commonsensically, we know the same point is same point will reach it again in the same direction after t seconds. Okay. Now, can you tell me this point? After how much time you'll reach this point, which is at a distance of, which is having a displacement of minus a by root 2. This point, the same point that you're talking about here, the same point here. Can you tell me? I'm talking about this point. Can you tell me after how much time we'll reach this point?
T by 2.
Very good. T by 2 seconds. Correct? Because to reach this point, it is t by 3, t by 8. And from here to here, you know, these 2 points have a time difference of t by 8. See here, we know from this analysis, same analysis here also. This point, and this point are at the same distance from the mean position. From the mean position, these 2 are symmetrical points. So time taken also will be symmetric. So t by 8 seconds. From 3t by 8, another t by 8 seconds, you'll reach the same point after t by 2 seconds. How about the corresponding point while coming from the extreme position, same point while coming back from the extreme position? After how much time it will do that? At what time that happens? Going from here to extreme position and then from extreme position to the same position, which is at a distance of minus a by root 2 from the mean position. What is the time taken? At the extreme position, it is 5t by 8. From 5t by 8, how much time it will take? Another t by 8. It will be 6t by 8, right? Or 3t by 4. Okay. Is it okay till this point? Anyone, any confusions?
No, sir, but we are unable to find the point where you
Yeah,
are
I
taking.
understand that. Yeah, once if you're able to see my pointer, then it will be easy to understand. I'll figure out something for the next class. You should have told me in yesterday's session also, no?
Yes, sir.
Yeah, you should tell me. Otherwise, how will I understand? Because this Zoom is very different. What I am able to see and what you are able to see is different completely. For me, cursor is moving. For you, it's not moving. So you have to let me know whenever there is some discomfort in what you are able to see. You should let me know immediately. Okay.
Okay, sir.
Okay. Okay. So fine. Whatever times we have talked about, right? Same times. Let us talk about the corresponding phase also. The way we have analyzed previously. Can you tell me? We know the phase corresponding to this point, right? Phase corresponding to this point is pi by 4. What is the phase corresponding to this point? Anyone?
Pi by 2.
Pi by 2 only, no? Because initially we have started with 0. We have started with pi by 4 phase. Initially we have started with pi by 4 phase. From that, a change of pi by 4 phase happened till this point. And from this point till this point, another pi by 4 phase change happened. So this point corresponds to, how much is it? Pi by 2 here till here. And from here to here, another pi by 4 phase change. So it is pi by 2 plus pi by 4.
3 pi by
3
4.
pi by 4. Okay. Now what is the phase corresponding to this point? Phase is pi.
Pi.
Same phases only. But the initial phase is different. That is the only change. Fine. Oh, I'll move to the next slide. I'll take some more examples. Okay. Are you able to see my cursor now?
Yes, sir.
When I'm
Yes, sir.
moving, is it moving?
Yes, sir.
Okay, good. Okay. How about phase 5 by 2? Initial phase is 5 by 2. Can you mark the initial point? Anyone? Can anyone mark the
C.
initial point?
C.
Where it is starting? It is
C,
starting
sir.
at C. Wonderful. The starting point, because the phase is pi by 2, you can substitute here x equal to a sine of pi by 2, and you're talking about time 0. At time 0, displacement is a sine pi by 2, which is a. So a means in the positive direction at a distance of a from the mean position. So it is this point. It's this point they're talking about. So this is the initial point. So what is the initial phase? Initial phase is pi by 2. And at time 0. Okay. So initial phase they might give, or initial displacement also they might give. From initial displacement, you can find initial phase. From initial phase, you can find initial displacement. Now, can you tell me what is the time? How much is the time taken to get to this point? How much is the time taken to get to this point?
Sir, from C, sir.
T by
P by 4.
T by 4. Only path. This is path 1. Path 2. Only path 2 it is traversing. No, only path 2 it is taking. Time taken for path 2. Only one of the paths. Among the 4 paths, the time taken to take one go for one path is T by 4, 1/4 of it. What is the time taken to go from B to D?
It will be also T
Another
by
T by 4. But total time from this position, what is the total time? Another T by 4.
T
So
by
it is T by 2. To come to B, what is the time taken?
You can
3T.
3T by 4.
So again, what is the next time at which that gets to the same point?
T.
T.
Very good. So can you tell me what is the time at which it gets to this position, which is at a distance of A by root 2?
T by 8, sir.
Excellent. So what is the time? T by 8. Now tell me what is the time at which it gets to the same A by root 2 point? This is A by root minus A by root 2 point. This is plus
T by 4, sir.
sorry.
From
What is the time
that
taken?
only. From A by root 2 only, no, sir.
From here. This is the starting position. This is the reference. From here you have to measure. Here at starting when you have observed, it is here. From here to here, how much is the time taken?
3T by 8.
Very good. Till here, T by 4, we know that much. And to go from mean position to minus A by root 2, to travel A by root 2 distance, how much time taken? How much time is taken? It takes T by 8 seconds, right? So T by 4 till this point, and from here to here, another T by 8. So it should be 3T by 8.
3T by 8.
Again to the same point, while returning back, same minus A by root 2 point, while returning from the extreme position, how much is the time taken? Who will tell me?
5T by 8. sir.
5T by.
Very good. See, till here it is T by 2 seconds. And from here to here, another T by 8 seconds.
7T by
70 by.
Very good. Okay. Now I'll ask you about a different point which you have not seen till now. Let's see who will answer me. I'm talking about this point, midpoint between mean and extreme positions. A by 2, not A by root 2, A by 2. How about this point? A by 2 here, 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 and here. This is minus A by 2 point. First, can you tell me what is this gap? The length, displacement wise, it is A by 2. Agreed. What is the time difference?
Let me know.
T by.
What is the time difference between these 2 points?
T by 8.
Why? T by 8, we have discussed it for this one, this point.
Is B is the initial point, sir.
I'm talking about the difference. No, when I'm talking about the difference, first let's figure out the difference. Okay.
Sir, is it T by 12? Sir?
T by 12, I think that should be correct. Okay. So to get a displacement of this change, or else this is the initial point, no? Okay. Irrespective of phase, the difference remains same. Whatever is the initial phase, irrespective of that, the distance between those 2 points, the time gap between those 2 points, phase gap between those 2 points, they all remain the same, irrespective of initial phase. Initial phase only tells us the starting place. Okay, but the gap between, when you're taking 2 points, the gap between them, the displacement gap or time gap or phase gap, they remain the same. Okay, so whenever you want to deal such things, you take A sin omega t, you take the previous case. When you take phase as 0, that's easy to analyze. Whenever you want to analyze few important things, it's better. Whenever you want to analyze the gaps, it's better to take analyze the phase 0 case. If you take phase 0 case, this is the starting point. So it will become x equal to A sin omega t. Now from here, you want to reach a point here, A by 2 point, right? So what is the displacement? A by 2. I'm taking initial phase as 0 just to calculate this. A by 2 equal to A into sine omega t or sine theta. So A cancel. What should be omega t? Omega 2 should be equal to 30 degrees or pi by 6, correct? How much should be the phase difference? The phase difference between these 2 points. The phase difference between these 2 points is how much? Pi by 6. If the phase difference between these 2 points is pi by 6, what is the phase difference between these 2 points? Anyone?
Pi by 6. Pi by 6 plus.
How much? it should be pi by 3. Because total is pi by 2, we know that, no? From here to here, it is pi by 2, that much we know. Mean and extreme, what is the phase gap? Pi by 2. Correct? So from here to here, to travel a by 2 distance from the mean position, what is the phase change? Pi by 6 is the phase change. And from here to here, phase has become pi by 2. From pi by 6, it has become pi by 2. What is the phase difference between these 2 points? These 2 points. Pi by 3 is the phase difference. Again, when you are coming back also, the same point, which is a by 2 point, what is the phase gap? From extreme to this point, what is the phase gap? Again, same pi by 3. Between these 2 points, what is the phase gap?
Pi by
by
6.
5 by 6.
Next, again, the midpoint here, a by 2, minus a by 2, minus a by 2 here. This gap, how much is that? From the mean position, it is pi by 6.
Pi by 6.
Okay. With small phase change, you are getting a lot of amplitude change because the velocity is more here. From the mean, when you're going from the mean position, velocity is more, that's why. So this gap is also pi by 6. This gap,
pi by
Pi by
3.
pi by,
5 by
okay. Okay, good. Now we have understood this. Yeah. So now can you tell me what is the time gap here? So we have understood the phase gap, right? From phase gap, can you tell me the time gap? So to travel this a by 2 distance, the phase gap is, sorry,
That will be
phase
up
gap
to
is pi by 6, right? Pi by 6. What does pi by 6 correspond to? Pi by 6 corresponds to 2 pi corresponds to t. What does pi by 6 correspond to? From 2 pi, if you want to get pi by 6, you have to divide with 12. So it should be t by 12. Correct? Pi by 6 phase corresponds to t by 12 seconds time. So it is t by 12. It takes t by 12 seconds from, if you want to go from this point to this point. Now tell me, from this point to this point, what is the phase gap?
T by 6.
Very good. What is the phase gap? What is the time gap?
T by
Phase
T by
gap is
6.
pi by 3. And what is the time gap?
T by 6.
Pi by 3 corresponds to t by 6. Okay. Next, can you tell me what is the time here? You know, time taken from the extreme position to this point, a by 2 point. This a by 2 point, from here to here, it takes t by 6 seconds, which means from C to this point, also it takes t by
T
6
by
seconds.
6 only.
Now tell me how much is the time here? This is the starting point. Starting point is 0 time, no? From 0, how
T
much?
by 6 only.
T by 6 only. Very good. How about this point? Can anyone tell me about this point? Till here it is t by 4. And to time taken to go from mean to this a by
Sir,
2,
it will be T by 12, sir.
pi by 6 is the phase difference. T
Yes,
by
sir.
12 is the time difference. So how much time is taken from to go from this point to this point? To go
T
from
by
this
12.
point to this point, it takes another t by 12. So time taken is t by 4 till this point, and from this point to this point, it is again t by 12. You can add both of them. So it will be 12. So it is 3 plus 1, 4, 4t by 12 or
T by 3.
t by 3. Very good. Can you tell me about the time for this one? From here till here. You're able to see my cursor, right?
T by 3, sir.
This is t by 3. Agreed. How about this one?
Sir, from which point, sir? Minus a by
All I
2.
was talking about starting position. This is the starting position, no?
Negative direction, sir.
See, I'm talking
Like-
about this point. This point means coming from the extreme position. The point which is coming from the extreme position. When the particle reaches this position, minus a by 2, in the positive direction, what is the time taken? This is the starting time. From here to come here, what is the time taken? From here, if you want to come here or here, it takes t by 2 seconds. And from here to here, what is the phase gap and time gap? Phase gap and time gap is pi by 3 is the gap,
T
and t by 6
T
is
by
the time gap.
T by
So
6.
now, sorry, from here. So what is the time taken? From till here it is t by 2, and from here to here it takes t by 6 seconds. So t by 2 plus t by 6, it is t by 2 plus t by 6. You can just leave it like that. And how from here to here, what is the time taken till this point? Till this point. Till here, we know it is 3t by 4. And from here to
Plus
here,
3 by 2.
it takes
T
t
by
by 12 seconds. Okay.
Okay, sir.
I guess you're following.
Yes.
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 Yeah.
Yes, sir.
Good. Similarly, if initial phase was pi, what would be the starting point?
Mean position.
At the mean position in the
B.
negative direction. Okay. If the initial phase was 3 pi by 4, where would it start? At what is the initial position? If phi is 3 pi by 4, then where would it start? 3 pi by 4. Phase measurement starts from the equilibrium position. Okay. 0, pi by
It
2.
will start from B,
3
sir.
pi by 4 means somewhere here, no? At a displacement of a by root 2, at a displacement of a by root 2 while traveling in the negative x direction. Displacement of a by root 2 happens while traveling in the positive x direction as well as negative x direction. While going from mean to extreme and extreme to mean, you two times you come across that point, a by root 2 point. Okay. When the phase is 3 pi by 4, you're talking about initial phase as 3 pi by 4 means you're talking about a point while coming back from the extreme position. This point. Okay. If phase is 5 pi by 4, then the starting position is this point, a by root 2, somewhere
Yes,
here,
sir.
somewhere here. If it is 7 pi by 4, if it is 7 pi by 4, it is somewhere here. Okay. Whatever is the initial phase or initial displacement, our measurement starts from that point. Okay. Similarly, can you figure out another point? I'll give you one more point, which is having an amplitude of root 3 by 2a. Which this point will be here also, root 3 by 2a. Root 3 by 2a. Can you figure out about this point? Talking about this point, root 3 by 2a, this point. I want this gap. First of all, you should know this gap and this gap. Not in terms of amplitude, I'm talking in terms of time and phase. So take a sine omega t. With 0 phase, you take it. And or else you can take 0 time also and then analyze also. That is also fine. You can take 0 time, then it
Pi by
becomes a sine phi equal to root 3 by 2a. Then a and a cancel, phi equal to 60 degrees or pi by 3. Which means at time 0, if the initial phase is 60 degrees, only then you start from this point. Which means this is the 0 phase point. This is the pi by 3 phase point. So what is the phase difference between this point and pi root 3 by 2a point? Pi by 3 is the phase difference. What is the time difference?
T by 6.
T by 6. What is this gap? If this gap is pi by 3, this gap should be phase gap should be pi by 6. And the time gap should be
T by
12. Following?
Yes, sir.
Now tell me, what does this point corresponds to? In this, when the initial phase is pi by 2, what is the time taken to come from this point to this point? This point to this point means it is same as this point to this point. How much is the time taken? T by 12. See, what is the time gap between extreme position and this position? Root 3 by 2 a point?
T by 2.
T by 12. So time taken is T by 12. Similarly, can you analyze the same points here also? Minus root 3 by 2 a point, minus root 3 by 2 a point, minus root 3 by 2 a point. So what you should do is, once you go back home, draw this diagram with paths 1, 2, 3, 4. And among these paths, there are, in one path, first path, 0 point is important, extreme point is important. We know about those points already. Apart from those 2 points, in between, there are 3 points that I've talked about. Because only for those 3 points, it is easy to find sine and cos values. Sine 30 is easy, sine 45 is easy, sine 60 is easy. I'm talking about those points. The points correspond to those phases. 30 degrees, 60 degrees, and 30, 45, and 60 degrees. I'm talking about only those points. So totally, between mean and extreme, there are 3 points that we have taken. Mean 3 points. Okay, so try to understand from the mean 30 degrees point, what is the time gap, phase gap? From 30 to 45, what is the time gap, phase gap? From 45 to 60, what is the time gap, phase gap? 60 to 90, what is the time gap, phase gap? You just try to analyze on your own. Once again, you take a bigger diagram and try to figure out those 3 points in between the mean position and extreme position. There are three points. 3 points here, 3 points here, 3 points here, 3 points here. Analyze the gaps. Once you analyze the gap, phase gap or time gap, then everything else we can find. We can just, if you keep adding them, you'll get it. Okay. What if they have given you some other point? That also we can find. We don't need to worry about it. Okay. Let's say if they have given some initial displacement, if they said initial displacement as some a by root 3, something like this, then what is the initial point? Can we figure out that? Initial displacement is a by root 3, means a by root 3 is equal to, what is the formula for initial phase? A sine of omega t plus phi. T put time 0. A sine omega into 0 plus phi is a sine phi. So a cancel, phi is equal to sine inverse of 1 by root 3. We don't know how much is that angle. Don't know. Only sine inverse of 1 by root 2, root 3 by 2, 1 by 2 we know. Other values we have to leave it like that. Okay, sine inverse of 1 by root 3. Okay, sine inverse of 1 by root 3. So if you mark that point, it is somewhere in this graph from mean position, extreme position, it is somewhere in between. Okay, we don't know exactly where it is, but it is somewhere in between. When they say initial displacement, you can figure out the initial phase. It's very rare they ask some points other than 30, 45, 60. Okay, when they ask some other point also, we can find the corresponding phase for that point. Okay, so this is a by root 3 point, let's say. Then the phase gap between these 2 points, when you find initial phase, that is itself is the phase gap. This gap is how much? Sine inverse of 1 by root 3. Can someone tell me what is this gap? What is this phase gap between these 2 points? This length is, this phase gap is pi by 2, no? This total is pi by 2. This part is only sine inverse of 1 by root 3. So what is the remaining? You know this? What is this much? From pi by 2, this total pi by 2, remove that, no? Following?
Yes.
Simple. If they have given some other amplitude where you can't find it, see, this is some angle, okay? So 1 by root 3. Root 3 means 1.732. So 1 by root 3 means how much is that? 1 by root 3? 1 by root 2 is 7.732. I don't know what is 1 by root 3. One divided by root 3. 0.577. 0.577. 577 means a little greater than 0.5. Little greater than the midpoint. So if this is a by 2, it is a little greater than the midpoint. So a by 2 means we know the phase, which is 30 degrees. So 30 degrees, it is little greater than 30, something like 33, 34, something like that. But since we don't know the exact angle, we are just leaving it as sine inverse of 1 by root 3. Okay. Just understand the gap. What is the gap from the mean position? What is the distance? Phase distance. And from the extreme position, what is the distance? Only those two are important for us. Don't try to find the distance between these 2 points. That will be, you can find it, but not that much required, but we can find it. It's not a big deal. You just need to figure out the phase difference and time differences. Okay.
Okay.
What if initial displacement is a by root 5? If initial displacement is a by root 5, the phase gap is sine inverse of 1 by root 5. This gap from this point to this point is sine inverse of 1 by root 5. And what is this gap? It will be pi by 2 minus sine inverse of 1 by root 5. Like that, if they give you some initial displacement, you can find initial phase. Though the phase is not 30, 60, 45 kind of thing, then also you can find it. Okay. Right. I understand you need more clarity on this. You have understood, but little bit more expertise is required. So we'll take 1 or 2 more examples in tomorrow's session, and then you'll get the confidence on it. Once you get the confidence, then problems will be like cakewalk. Fine, then we'll stop at this place. We'll meet tomorrow at the same time. Okay.